Hello everyone, my name is Ananya P. Tankar and today I shall be talking about insertion sort, which is a sorting algorithm. Insertion sort is a comparison-based sorting algorithm that builds the final sorted array one element at a time by repeatedly picking the next element and inserting it into its correct position among the already sorted elements. It follows decrease and conquer method, that is, it reduces the size of the problem in order to solve it. Now, I shall explain the steps to solve a problem using insertion sort. In step 1, we start from the second element because the first element is already sorted. We then compare the current element to the ones before it, that is, the elements which are to the left are compared. If the element in step 3, we shift the elements to the right if it is larger than the current element to make space. In step 4, we insert the current element into the correct position. We repeat step 4 until all elements are sorted and the final sorted array is made. Here in this example, let us do a small exercise to better understand the steps involved in insertion sort. Here we have an array of elements 12, 6, 8, 4 and 1. Here the size of the array is 5. Now 12 is already sorted, hence this is the 12, hence this is the sorted subarray and this is the unsorted subarray. Here 12 is the first element and it is already sorted, hence we start from the second element, that is 6. In the first pass, we need to insert 6 into the sorted subarray. To do that, we first compare 6 with the element to its left, that is 12. Since 12 is greater than 6, we shift it to the right. And we shift it to the right to make space and insert 6 into the sorted subarray. Hence, we get the array as follows. We get the array as. Let us do a small exercise to better understand the steps involved in insertion sort. Here we have an array of elements 12, 6, 8, 4 and 1. Here the size of the array is 5. Here 12 is the first element and it is already sorted. Hence, we start from the second element, that is 6. In the first pass, we need to insert 6 into the sorted subarray. To do that, we first compare 6 with the element to its left, that is 12. Since 12 is greater than 6, we shift it to the right. We shift it to the right to make space and insert 6 into the sorted subarray. Hence, we get the array as follows. 6, 12. So far this is the sorted subarray and the remaining elements which are unsorted belongs to the unsorted subarray. In the first pass, we have maximum of 1 comparisons and we can do maximum one shift or one swap. In the second pass, we need to insert the value 8 into the sorted subarray. To do so, we compare 8 with 12 and 6. Since 12 is greater than 8, we shift it towards the right to make space. And then we compare 8 with 6. Since 8 is greater than 6, we don't have to do any shifting. Hence, 8 is inserted before 12 and the array is as follows. Now this is the sorted array and this is the unsorted array. Now in the third pass, we need to insert the value 4 into the sorted subarray. To do so, we compare 4 with the elements towards its left. Since 12 is greater than 4, we shift it towards the right. And 8 is also greater than 4, so we again shift it towards the right. 6 is also greater than 4, so again we shift it towards the right to make space. In the space here, we insert 4, and hence the array is as follows: 4, 6, 8, 12. This is the sorted array, and this is the unsorted array, which is 1. It has only one value. In the fourth pass, we need to insert 1 into the sorted array. Again, as done in previous steps, we compare 1 to the elements on its left. 12 is greater than 1, so again we shift here. 8 is greater than 1, shift. 6 is also greater than 1, again we shift to the right. 4 is also greater than 1, we shift again, and the space which is left here, we insert 1 over here, and hence the final sorted array is as follows: 1, 4, 6, 8, and 12. This is the final sorted array. Now, in each pass, there is a maximum number of comparisons and swapping or shifting done. In the first pass, we have maximum of 1 comparisons and 1 swapping. In second pass, we have maximum of 2 comparisons and 2 swappings. In the third pass, we have maximum of 3 comparisons and 3 swaps. In fourth pass, we have 4 maximum comparisons and 4 maximum swaps. This is how we solve a problem or sort an array using insertion sort. Now, let us look at the algorithm for insertion sort. In this algorithm, we input an array of size n and we obtain the final sorted array as the input. We start the for loop from the second element, that is 1, and then we iterate through n minus 1 elements. Here we have an example with 6 elements. We iterate from position 1 to 5, that is n minus 1. X is the current element, that is I, and j is the element before it, that is I minus 1. And j is the position before I, that is j is equal to I minus 1. Now let us look at the conditions of the while loop here. Here, as long as j is in range, that is as long as j is greater than or equal to 0 and the value at position j is greater than x, we shift the value at j towards the right and we decrement j by 1. I'll explain this. Here we can see that the sorted part starts from index 3. Unsorted parts ends to index 2. Here let the current element be I. So the j will be here. Now the x equals 1 as given in the pseudocode, as given in the algorithm. Now as long as j is greater than or equal to 0, that condition is fulfilled. Now the value at position j is greater than x, so we move it towards the right and we decrement j. So now j is here. Again we compare it with 1. Again it is greater, so we shift towards the right and then we decrement j. Now j is at position 0. Again 4 is greater than 1, so again we shift towards the right to make space and then we decrement j again. Now once we decrement j, the value of j is now minus 1, hence it is no longer in j. This condition is no longer fulfilled, hence it exits the loop and we assign the element x to the current position, that is j minus 1. Here we assign 1 over here and we continue this same procedure for all the elements. Here we have another example which I shall discuss. We have it's a simple example. We have an array of 4 elements, 40, 13, 20 and 80. Since 40 is already sorted, since it is the first element, we have the sorted part and the unsorted part. We start with 13, we compare it with 40. Since 13 is lesser than 40, we insert it before 40 and we get this array. And then we pick 20, which is the next element. We compare it with the left elements, that is 13 and 40. Since 40 is greater than 20, we shift it towards the right and then we insert 20 before 40 and hence we get this array. Then we pick 8, which is the last element. we compare with all the elements towards the left. Since 8 is lesser than all the elements, we shift all the elements towards the right and then we insert 8 at the front. Now let us look at the time complexity of the algorithm. If you look at the example which we have done, in first pass we have one comparison, one swap. Second pass we have two comparisons and two swaps. That is the maximum number of comparisons which can be done in the second pass is 2, and the maximum number of swaps which can be done in second pass is also 2. So if we add the number of comparisons and swaps, we get the time complexity of the algorithm. Even in the algorithm, if you see, there are two loops. One is a nested loop. So by looking at the algorithm itself, we can determine that the time complexity will be that the order will be n square. Now let us analyze the time complexity. In the best case scenario, we will have an array that is already sorted. For example, we have 4, 6, 8, 12. This array is already sorted, so only comparison is done here. Suppose the current element is 12, we only compare it with the sorted part. There is no shifting done, so the time complexity will be big O of n. In the average case scenario, the elements will be arranged in a randomized manner. 6, 4, 8, so on. Now, on average, each element is compared with half of the sorted part, so the time complexity is big O of n square. In the worst case scenario, we have to sort the array in reverse. Suppose we have to sort the array in ascending order and the elements are in descending order. We have to compare the current element with each of the sorted part and also shift each of the elements. Hence, again the time order is big O of n square. I'll show you how to determine it using the number of swaps and comparisons as well. Here, let us go to our example and count the number of comparisons done. Number of total comparisons. For 4 passes, we have 1 plus 2 plus 3 plus 4 comparisons. However, for n elements, we have n minus 1 passes. As you can see, for 5 elements, we have 4 passes, so n minus 1 passes. So for n minus 1 passes, we will have summation of n minus 1. So we will have n into n minus 1 divided by 2 number of comparisons for n minus 1 passes. So we can determine as n big O of n square. Similarly, the total number of swaps are also similar. We have 1 plus 2 plus so on till n minus 1 is equal to n into n minus 1 by 2. Again the order will be big O of n square. Now let us analyze the space complexity of the algorithm. Insertion sort is an in-place algorithm, which means it does not use any extra space for another array or data structure. It only uses a few temporary variables for storing the current element and index positions during shifting. There is no additional memory required, as regardless of the size of the input array, the extra space used remains constant. Insertion sort is memory efficient and it is suitable for memory constrained environments or embedded systems. Now let us discuss about the uses of insertion sort. Insertion sort is simple and works efficiently for small arrays. It is used in real-time systems with small data and minimal overhead because it requires no extra memory. It is easy to understand, so it is widely used to teach sorting concepts. Insertion sort is used to maintain sorted lists as new elements arise. It is good for cases where data is added one at a time and needs to stay sorted. Insertion sort is also designed for linked lists, as elements don't need to be shifted to be inserted in linked lists. Thank you for watching. Don't forget to like the video and subscribe to my channel. Have a nice day.